Okay, today we're going to talk about parent functions. We're going to see who is listening to my notes and who is actually just writing things down. Please do not copy down this page. I have printed this page for you. I made the copies, I should say. I'm going to hand you this copy so that you have it in your notes. If you prefer to write it down in color, that's fine. Otherwise, when I give you the copy in class, you can just highlight what I have in pink and a highlighter. All right? Parent functions. What is a parent function? The parent function is the basis. This is the generic, as you could call it, function or graph of any formula or function that we come across. So what is the basic? Well, a linear function, okay, is a line. How do you remember that? Let me use yellow. One second. Because it has the word line in it. Linear, line, okay? The graph looks like a line, okay? What does that formula look like? Y equals X. Okay, so as you multiply numbers, y equals 3x. So let's look at this. Let me go to my y equals. If I type in x, there you go. You have the parent function. If I go to y equals, and let's say y equals 5x, now it's more steep, but it's still a line, okay? If you type in y equals, let's do this, 5, let's switch this, 3x plus 4. I'm now going to switch the slope of the line and shift it up. Okay, we shifted it up on the y-axis. But everything starts with y equals x. All right, exponential function. An exponential function is a curve, and it is ya to the x power. Okay, exponential decay, it goes up and you have a large drop. Exponential growth, you're going to grow real slow and then boom, you're going to have a really high, a large growth. Okay, a quadratic function, it looks like a parabola. And the basic formula is y equals x squared. Okay, now we're going to take this parabola and we're going to, here in a minute, we're going to stretch it. We're going to compress it. We're going to move it. And that's what we're going to focus on today is the quadratic function. But the parent function is y equals x squared. And this is what it looks like. Okay, if you want to look at that in your calculator, if you have x squared and you graph it, there's your parent function. All right, so we're going to look at some things and how does that change. All right. Now, there is a difference. I also have this handout for you. Please do not write it down. I have this handout for you in class. Please do not write it down. Okay, so there's a difference between the standard form and the parent function. The standard form is ax squared plus bx plus c. The parent function is y equals x squared. The quadratic transformation. So we're talking about the parent functions and the transformations that can take place on a quadratic function. So the changes to the graph of the parent function. So if we number with the x squared, the a affects the width. Okay, so this a right here, the a that we've been talking about, it's going to affect the width. When a is bigger, the graph gets narrower. Okay, so it actually now calls it that it stretches. Now, you have to think of it like this. Think of it like a rubber band. Think of it like a rubber band, okay? If this is my quadratic, as it gets more narrow, it stretches, okay? But if your a is a smaller number, it gets wider. We're going to say that it's compressing, okay? So you kind of have to keep those straight. So if the a is bigger, you're going to stretch it. If the a is smaller, it's actually going to compress, which means it's actually getting wider, The sign of the number with the x squared a affects the direction of the parabola. So if a is positive, the graph's going to go up. So you're going to have a minimum value. If the a is negative, the graph's going to go down and you're going to have a maximum value. Addition or subtraction. Inside parentheses, the graph shifts left or right. So if we have x plus 7 squared, the graph shifts left 7 units. X minus 7 squared, the graph's going to shift to the right 3 units. Okay? Addition or subtraction outside parentheses is going to shift our graph up or down. So x squared plus 2 shifts it up 2. X squared minus 5 is going to shift it down 5. So we're going to work on these a little bit. These are the notes that you need to write down. Okay? Write these notes down. I do not have a copy of these notes. This is the only page you should write down. G of x equals negative 10 plus x squared. Okay? You can rewrite this. So it says G of x equals x squared minus 10. That means we're going to translate our parabola down 10 units. So watch this. Then my parabola is going to come all the way down to the end of my screen. X squared minus 10. Okay, the vertex is all the way down at the bottom, but I still have the same width. All right. H of x equals negative 7 minus x squared. Okay, well, it reflected across the x-axis and it's translated down 7 units. Well, let's look at that. Okay, so you can always put in your parent function first into the calculator and then see what happens. So we're going to type in negative 7 minus x squared and hit graph. Parent function. Oh, see, look, see, it's all the way down here. So it flipped it upside down and it moved it down. So right here, it's crossing at the 7 and it flipped it over, okay? So let's look at the next one. F of x, 2/3 x squared plus 6. Well, let's think about this. 2/3, did my a get big or small? If there's nothing in front, there's just a 1. So is this smaller than 1 or larger than 1? Correct. It's smaller than 1. Okay, so let's put this in the calculator here. Make sure you put your fraction in parentheses. X squared plus 6. Okay, now this is going to stretch. It's going to get more narrow. It's going to stretch up, okay? Parent function. And then it stretches and gets more narrow, okay, up at the top. But it also shifted up 6. Let's see what we have here. It says the graph gets, wider and compresses. See, I even messed that up. Let's see here. Oh, A is smaller. Oops, see, look, I messed up. When A gets smaller, the graph gets wider. And that's what that did. So, see, I messed that up. That's one thing I have to keep straight too. When A gets smaller, the graph gets wider. Okay. Okay, so let's look at this one. Parent function, 2 open parentheses, x minus 3 squared plus 8. Okay, now I'm going to fix my window if you'll watch me here. It's real hard to see what's going on with our parabola, so I'm actually going to hit window. Now, this is asking about our x values. We don't need to go with our x values. We actually need to lift our y values up. So the y maximum is only letting me go to 10. Let's go ahead and bump it to 20. There, that gives us a little better picture, okay? So what's taking place on this one? Well, it says it translated it to the right 3 units, okay? it translated up 8 units. So right 3, up 8. It gets more narrow or stretched because our A now is larger. And how do you figure all of that out? Okay, so right here, x minus 3, you actually have x minus 3 times x minus 3. You can FOIL that, and x times x is x squared. X times negative 3 is negative 3x. Then inside, negative 3 times x is negative 3. And then your last is negative 3 times negative 3 gives us a positive 9, okay? So now this is inside our parentheses, okay? So what I did is I took that and I translated it into this. Are you with me? So now I'm going to take that and I'm going to stick it into my formula where I put a 2 in front, and I'm going to add my 8 to the back. All right? So now I have 2 times x squared, and then I have to I'm distributing. So 2 times x squared gives me 2x squared. 2 times negative 6x gives me negative 12x. And 2 times 9 gives me 18. And I still have a plus 8. Then I have to combine like terms. So I have 2x squared minus 12x plus 26. And right here, the 8 gets bigger, which means it's narrow and it's stretched. Okay, so we're going to work on some of these problems in class on Monday. Remember, this is the only page you should have notes on. The other ones I'm passing out to you, so as handouts to you on Monday in class. Thank you.